there are many types of graphs showing motion. One which is very rare, which is very rarely shown, is called the position time graph. Then we have the distance time graph. Then we have the displacement time graph. Then we have the speed time graph. Then we have the velocity time graph. Then we have the acceleration time graph. So we have got quite a few types of graphs. You will have to try to understand that each has got a, a different understanding, and we will discuss all these. Now, first I will come to the common ones which you are aware of. You see, these two, this is a scalar and this is a vector. So similarly here, this is a scalar and this is a vector. One thing is clear, scalars can't show direction and vectors can show. That we know from theory. So this can show direction, this can show direction. So how do we show direction on a velocity diagram? That is the critical point. We show direction by plus and minus. It's in a straight line motion. If it's in a straight line, like if a body is going here, we say positive, and if a body is going here, we say negative. This is the direction. If you throw the ball up, it goes positive. If you take the positive direction as up, then it goes up and falls down. That's negative. So at this moment, look, now you have to understand that what difference does this make to the graphs? Okay, so what is happening is we have got two graphs here. I will first talk about distance and displacement time graph. So let us say you throw a ball from here. This is let's say some hill or some this thing, and you are thrown a ball up. You take the upward direction of now this is immaterial. Whether you take it up or positive, that's not important. We always, whenever we are talking of you see there is two graphs here, and position time and displacement time and distance time. Position is we talk about some positions, but I'm kind of ignoring this right now. This will be important, otherwise they don't teach this properly. It is going to be useful in ASA level in mechanics, and you won't understand a damn thing if you don't understand this, but I will come to this later. Okay, now this is the displacement till he goes up. It is positive displacement, and then it starts comes here. It's still positive. It's still like, supposing I have this as zero level. Let's say this is, let's say this is 10. Let's say this is 20. This is 30 meters, 50 meters. Then it comes to 30, again to 30, and again to 20, again to 10, again to 0, and then something different happens. It's going down now. You see, yeah, I mean, this was also, it was also going down here, but the value was such with respect to the initial position, the displacement was still 30. But now it is with respect to this, it is minus 10, minus 20. We always talk with respect to the initial position, okay? Initial position. So this, when it is here, it is plus 10, 30. It's still high, na? Okay. Though we are going down, the velocity has become negative. The velocity has become negative, but the displacement is still positive. Okay. Okay. Now we come here and we go to Acha. Now this is the displacement. I'm talking of the displacement. I have talked of the velocity. Here the velocity was positive. Here the velocity is negative. Here is still negative. Okay, we have got velocity. I've divided this into three phases. This is positive displacement. This is positive displacement. Here it becomes negative displacement. So in each phase, Here velocity is positive and displacement is positive. Here velocity is negative, displacement is negative. Positive displacement is positive, velocity is negative. Here both displacement and velocity are negative. Okay, now we add another thing. We add distance to it. What is happening here? Distance. Distance, can it be positive? Can it be negative? No, it is only positive. So that means here displacement distance is positive. Distance is positive. Here what happens? Here also it is positive. It can't be negative. It's a scalar. What about this? Also positive. Also positive. So now we start thinking of how to draw the graphs and what difference will it make. Now it gets confusing. So first we start with the displacement time graph. We find that as time is increasing, as the time is increasing, the velocity is slightly decreasing. So it, but the distance is, I'm putting displacement here, okay? So, and time here. It goes on increasing, it becomes plus, 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 plus. Velocity here goes on decreasing. The slope is going on decreasing. It becomes zero here. The slope becomes zero here, and then it starts going down. But it's still positive. Displacement is still positive. It comes and comes and comes and comes, and it becomes zero. And then it becomes negative. Then the displacement. Now notice the slope. The slope. The slope is I put it here, okay? I will explain this tan theta thing slightly later, but first try to understand the slope is the angle, and so the angle goes on. We what do you see? The angle goes on decreasing. The angle goes on decreasing, and it has become zero here. So this is what is happening to the velocity. Velocity is positive, angle is positive, and it goes on increasing, decreasing. What is happening here? Now see, there's a small difference. Now this I will teach tan theta. This is an acute angle. The slope is an acute angle. Once it crosses here, it becomes obtuse. Whenever we take the angle, we always we take the angle with respect to the horizontal. So here the angle is obtuse. Whenever it turns obtuse, it is negative. I will explain why later. So it turns negative. So now we have negative velocity. It's negative velocity while it's going down. And again, it remains negative. Now here, what is happening? The displacement is positive. The velocity is positive because it is acute. Here, displacement is positive. Displacement is still positive. Velocity is negative because it's going down. And here, displacement is negative and velocity is negative. It's going down. Now, to differentiate, to show you the difference between displacement and distance graph, I now draw the distance time graph. Now, the distance time graph will be the what do we see? We see it will follow what is happening. The distance is increasing. Yes, it is increasing when it goes up. So it's going. It just follows the displacement time graph. So for this part, it is same till it goes to the top because this is in the same direction, straight line. Distance and displacement are same if an object moves in the same direction. Now something else happens. It's coming down. Here the displacement turns reducing, but here distance is just adding. And it keeps on adding because it can't be negative. It has to be positive. So then what happens is it goes like this. That's where the difference starts. It can't be negative. It will not come down. The distance time graph will not come down. What about the slope? The slope again the same thing. Theta goes on decreasing, theta goes on decreasing, theta goes on becomes zero. Then again it increases. But what are we showing? We are showing the speed here. We are not sure. Uh-huh. We don't the speed, slope of distance time graph is speed. Hmm. So you see, it's the speed is first decreasing and then it's increasing because coming down, but it has to be positive. And just for a moment, it's zero. Actually, when it just goes to the top, right? but it's the this is a point of inflection, we call it, and acceleration is still there. Okay. If you know, you will if you know differentiation, do you know differentiation? Oh, I were to draw. So this was the speed time graph. Okay. So how was what's the speed? If I were to draw the speed time graph of this, the speed is thrown with high speed. So it's thrown with high speed and it gradually decreases. It becomes zero and then it increases. This will be the speed time graph. It can't be negative. That's why the slope here, this is the slope. It is first decreasing, becoming zero, then the slope is again increasing. So the speed is again increasing. So this is the downward, this is the upward journey, and this is the downward journey. Now supposing I were to draw the same thing with the velocity time graph. Okay, so I draw the velocity time graph. Now, what is happening in the velocity? The velocity is positive, but it's the slope, but it's decreasing again. The same thing happens. It follows the speed. Then it becomes it becomes negative, and so it's kind of going down. So the velocity is going on increasing, but it's become negative because this acceleration is there. No, acceleration is in the downward direction. So when the ball was thrown up, now what's acceleration? Acceleration is the slope. So acceleration is, yeah, changing. So this is the slope. Now what is this? It is acute angle, obtuse angle. So when it's obtuse angle, the acceleration is to be negative. Now it's negative. Why? When you taken it up as positive, ball goes up. The acceleration is down. Is g 9.8 is going down. So it's negative, and the speed is gradually decreasing. And from a positive some speed, let's say 5 meter per second or 15 meter per second, goes to zero, because as the ball goes up, it goes on reducing, then it goes downward journey, it becomes negative. It first becomes -5, -10, and then the speed is again going to -50, and depends on the distance. So this is the velocity time graph. So very different from the speed time graph. And supposing I were to draw the acceleration time graph, it will be this. It will be just this. -9.8. If I take upwards direction as positive, it will be constant because these are the three. If you understand this, then you understand the difference of all